Record. I was having trouble getting on Zoom this morning. I mean, right now. I don't know what was wrong with it. Okay, I'm going to close the window and without further discussion, let's get going. Let me erase the board. Almost done with falling. One more week. And that's going to be it. You guys probably are aware that the pandemic situation is getting worse with time. With this winter, I had thought that the temperature may not have so much effect on it, but apparently it does. Okay, I ran out of paper towels. Maybe I have something here. This is part of the ritual. Maybe I'll save it. All right, we are Chem 8, Tuesday, Thursday. Chem 8, Tuesday, Thursday, fall 20. And today is 12/3/2020. Okay. Carbonyl chemistry. Okay. So this is a carbonyl. That's a carbonyl. This is carbonyl chemistry. So we're going to talk about blurry. Uh-oh. I'm going to raise the volume so that I can hear you when you guys say it's blurry. I could barely hear you. Okay. It's going to play with us. Okay. So we're talking about the last stretch of our run. Okay. Carbonyl chemistry. We are going to deal with 7 different types of compounds. Don't get too worried. 2 of one kind, 5 of the other kind. And I'm going to try to draw some kind of similarity between all the 7 compounds so that you can learn it more easily than going all over the book. The book, this is probably when I deviate the most from the book. I don't like the organization of the book or books. I like to teach it this way. Okay. So we're talking about carbonyl chemistry. And this is carbonyl. This guy is called carbonyl, C double bond O. Okay. So when you have a carbonyl molecule, you can have a bunch of different things on the 2 other sides. Okay. So you can have something here, and you can have something else here. Depending upon what you have on the 2 ends of the carbonyl carbon, the molecular properties will vary. Okay. If you have 2 hydrogens, it's one kind of a molecule. If you have hydrogen and a carbon, smallest carbon would be CH3, that kind of a fragment. So that'll be another kind of a molecule. If you have 2 carbons, 2 CH3, that's another kind. What if you have an aromatic ring? What if you have a benzene ring and a hydrogen? What if you have a benzene ring and a CH3? What if you have 2 benzene rings? Now, what if you have something else on one side? Like you have a hydrogen or a carbon on one side, and you have, I don't know, oxygen or nitrogen or a halogen on the other side. What kind of properties will they acquire? So that's our discussion. We'll try to simplify it and make it as simple as possible so that you guys don't suffer too much during the last stretch of our run in the fall, okay? So on the left side, it's always going to be either something with a hydrogen, not something with a hydrogen, either a hydrogen, that I unnecessarily complicated it, either a hydrogen or a carbon of some kind, okay? We will go through a lot of examples. So one thing that can be here is a hydrogen, or it's going to be some sort of a carbon. Okay, and I'll draw a bunch of different examples so that you know what we're talking about. On the right-hand side, blurry?
Blurry.
Okay. I have to ditch this camera pretty soon. I tried to fix it. Yeah, I don't know what it's thinking. It thinks it can outsmart us. So on the left side, hydrogen or carbon. On the right side, there can be two different types of scenarios. One type of scenario is when you have hydrogen or a carbon, right? So this is one combination. On the left, hydrogen or carbon. On the right, hydrogen or carbon. That's going to constitute one type of compounds, actually one group of compounds under carbonyl, and they're going to be called aldehydes or ketones. Down here, you don't have to put a hydrogen or a carbon on the right side. On the left side, hydrogen or carbon. On the right side, it can be something with an oxygen, okay? Or something with a nitrogen, or a halogen. X means halogen. X means fluorine or chlorine or bromine or iodine. Okay. Now, what I would like to do, this is exactly what I did in my Monday, Wednesday, Friday class yesterday. We drew a bunch of different compounds and then we ran out of time. I kind of regretted doing that, but I think it's better for you to understand what these molecules might look like. I mean, if you see this, with your limited exposure to chemicals and organic molecules, you might not really have a good feel for what kind of molecules are we talking about. So let's start drawing some examples of these sort of molecules. Then we'll get into the reactions. Then we'll talk about the two different kinds of reactions. Then we'll go through the reactions, and that'll pretty much be it. Okay, we have one more lecture on Tuesday, and we have a quiz too, quiz number 4. So what I'm going to do right now is examples of these molecules, okay? So we're going to just go through examples. And we will do some simple nomenclature, not like heavy-duty, hardcore nomenclature, but some simple nomenclatures, and I'll tell you which names I want you to remember, okay? Hopefully that'll help. Okay, ready? Okay, number 1. A carbonyl, and think about the smallest element on its two sides. What would that be? What's the smallest element you can stick to the two ends of the carbonyl? I'm picking up my blue pen.
Hydrogen.
Hydrogen. This was Trinity. Thank you, Trinity. So yeah, so we can put a couple of hydrogens here. I will name them and classify them under the different functional groups just a little bit later, just hang in there for like a few more minutes. All right, so now let's put a carbonyl, okay? Let's put a hydrogen on the right side, but on the left side, let's stick the smallest carbon branch. What's that branch called? One carbon and few hydrogens. Tell me what I'm talking about. I wanna stick that here.
Methane.
Carbon, sorry?
Methane.
Not methane. Methane is the whole molecule. When methane is present as a branch.
Oh, methyl.
There you go, methyl. Very good, thank you. So, and this is it. You guys should be pretty comfortable with stick diagrams. skeletal diagrams, that means it's a methyl group, CH3, okay? So when you have a functionality, including carbonyl, okay? The functionality is the general name for the C double bond O is carbonyl, but depending upon what you have on both sides, or usually one side, the entire name of the functional group is determined. Functional group means something like OH that makes a molecule alcohol, NH or NH2 that makes a molecule an amine, okay? Things like that. So the group that makes me special, because alcohols are different than amines. Alcohols are different than alkanes. Alcohols are different than alkenes. So that OH gives the functionality or the special properties of that molecule, and that's a pretty big deal. So over here, for these two guys, it's this carbonyl and the hydrogen on one side that creates a certain type of property, very unique type of property that gets them a separate chapter sometimes, or a section under a chapter, okay? So this group is the first functional group that we're going to be talking about. There is a name for that. It's not alcohol, it's not amine, it's not ether, it's not ester. Does anybody know what CHO group is called? It's also an A word. It's
Alcohol?
A then L.
Alcohol?
No, this is alcohol. This is alcohol. This is alcohol. Anybody knows? If you don't know, then don't know. That's fine. You're not supposed to know unless you have read the book. Probably nobody is reading the book anymore. Anybody read the book? No. Anyone? One more try.
Aldehyde.
Go ahead, Trinity.
Aldehyde.
Sorry, no bonus points. So when you have this business, carbonyl with a hydrogen, it's called an aldehyde. I can't spell aldehyde. This is an aldehyde. That's also an aldehyde. So that's human, right? Under human, we are Trinity and Angelica and Vincent and all these names, right? Louis, Shantanu. So this particular aldehyde, when you have two hydrogens on the two sides, this is something that has a very pungent smell. I'm trying to get it out of your system. I'm trying to squeeze the name of this molecule from your brain, from your vocal cord. It's used for keeping dead species unrotting. It's an F word.
Formaldehyde?
Formaldehyde, there you go. It's a formaldehyde. So this is the name of the functional group, and this particular dude is called formaldehyde. This is, maybe you should remember that. Yeah, it's not that difficult. This is called acetaldehyde. You know what? Let me write it down. Why not? Acetal, ACE. Maybe I should not use cursive. ACETALDEHYDE. Acetaldehyde. This group is acetic. It comes from acetic acid. We will talk about it a little bit later. You will understand why it's called acetaldehyde in a few seconds. This is acetaldehyde. Since we are on the aldehyde, let's draw like a fancy spancy aldehyde. I'm going to ask you something pretty soon. When I said fancy aldehyde, what do you think I have in my mind? What do you think I'm going to stick to the left side of the carbonyl? Anybody wants to read my mind? There was one person who could read my mind earlier. Do you know what I'm going to stick there? Something with a carbon, but it's going to be looking like a really beautiful molecule. Anybody? What do I have in my mind? a very good looking, fancy stuff. Anyone wants to read my mind? What did we study before nucleophilic substitution reactions? Something that a person dreamt of and saw some creature chasing its tail. Those are called some sort of an A molecule. The word starts with A and they have some smell. And the molecule that we discussed, what is that B word? It's got a pretty good looking geometrical shape. What is it?
Benzene?
Benzene. That's a legitimate aldehyde. You have to have a carbon. There is a carbon. No one says that it has to be an sp3 carbon. It can be an sp2 carbon. It can be an sp carbon too. Who cares? It's a carbon, right? There is no, thank you, Viviana. There is no restriction there, okay? This is also an aldehyde, and this, anyone wants to take a shot at it? What could be the name of it? Mix the two words, aldehyde, benzene first, and then aldehyde. How do you mash them together? If you're a linguistics major, then you could probably do it. You can still do it. Benzene, take the word benzene and take the word aldehyde and stitch them. Take a shot.
Benzaldehyde?
Sorry?
Benzaldehyde?
Yes, it's called benzaldehyde. That's perfect. That's very good. I like the way you tried. Benzaldehyde, but it's called benzaldehyde. Very good. I'm impressed. We are running out of space. I need space. This board is too small. Okay, benzaldehyde. That's pretty good. Okay. Now, so these guys, all these guys are aldehydes. Okay, these guys are aldehydes. You could even have like a cyclohexanary. That's another aldehyde. Let's not dwell on aldehydes anymore. Now let's go to the next category of compounds. Okay, carbonyl. And I want to put no hydrogen on either side. Okay, so we are done with putting a hydrogen. Now, on one side, carbon, another side, another carbon. What could be the smallest such thing in the history of organic molecules that will have a carbonyl and the two smallest carbon thingies? What group am I thinking? Somebody helped me earlier, Trinity. Somebody else can try. You don't have to be answering all the time. What group shall I put there? Smallest alkyl chain. Sorry.
A methyl group.
Methyl group. There you go. This, by not having a hydrogen on either side, it's not an aldehyde. It's a different molecule. There used to be a shop where I need to visit very urgently. Actually, I'm trying to make an appointment with our barber who used to have a shop in Student Center. Her name is Penny, not that you care about all the details. And she once told me that we used to go there for our haircut, our son and me, for the last 12 years. And she said something very funny. I think I should share this story with you. She said that I'm one of the very few, maybe a handful of faculty members who gets their haircut over there. And she said, I wonder why. Are you guys shy to get your haircut in front of your students? And I don't know. I mean, I have asked some of my colleagues that, why didn't you guys go there and get your haircut? And nobody gave me a very, believable answer. So anyway, so she quit her job because nobody wants to get their haircut there. But she's a pretty good hair barber, hair cutter. So anyway, so when you pass by her shop, you smell that chemical. And again, the name of that molecule starts with an A, and it's used for removing something, a beauty product.
Acetone.
Go ahead, finish.
Acetone.
Acetone, there you go. Acetone. Acetone is the name of the molecule. Very good. And they belong to a certain category when you have a carbonyl and two carbon, something with two carbons. It's a K word. Anybody knows? You have heard it. They call that, like, they take the first few letters and they call it something diet. Do you know what
Keto.
Yeah, keto diet, but the name of the functional group is not keto. It's got two more letters.
Ketone.
Ketone, there you go. Fantastic. Awesome. Finally, you guys are responding. You could have done this like 3 months ago to keep my sanity. Okay. Ketone is carbonyl with two carbons. Okay. So let's draw maybe another little fancier ketone. You know what I'm going to do. Carbonyl. Let's stick a methyl on one side. And on the other side, let's put something good looking. Ooh, a beautiful hexagon. I'm so excited. Another ketone. Because carbonyl, carbon, carbon. That's all you need to know. Okay, carbonyl, carbon, carbon, nothing fancy. Not another carbonyl. Then it's a completely different story. Don't play games that way. Like if I say draw a ketone and you draw a carbonyl and a carbon with a nitrogen and an oxygen and a carbon with a double bonded oxygen, that's not a ketone, because you need to have like carbon with like normal stuff, like another carbon and hydrogen. So this is good. No one says that it cannot be an sp2 carbon. So that's a fair game. The name of the molecule, shall I talk about it or shall I not talk about it? I'll talk about it. It's called acetophenone. It's not going to be asked in the exam. This is just for your thirst, to quench your thirst, as if you are really dying to know that. Might be, who knows? This guy is called acetophenone. I'm going to put it in parentheses. It's not important for your exam, for the last quiz and the final. Okay. Another, because I don't have any room anyway for drawing the other compounds. So let's just fill up the board with some other ketones. 2 benzene rings. This guy is called benzophenone. Benzene, and phenone. The phenyl word is also has to do with benzene ring. I'm not going to go over that with you guys. I'm not dumbing it down, but I don't think you need that right now. Benzophenone, again, this is not important for the exam. So it's in parentheses, but you know, if you put the name in there, you're not going to get any extra credit because it's going to be all graded by Canvas. So these are some of the compounds that belong to certain category of carbonyl compounds. So I'm going to write it down. So one category under carbonyl . So carbonyl compounds . Carbonyl compounds, and then there are two kinds, two categories. One category is aldehydes and ketones. That's usually taught in one chapter. Aldehydes and it's pretty stuffy. I'm going to just prop open my door. I think they're messing with our temperature. It's really hot. Aldehydes and ketones, they are one kind of molecules, all these guys, okay? Remember that I will expect you to know what makes a molecule aldehyde, what makes a molecule ketone. If I just say some really simple, trivial questions like identify this compound, is this an aldehyde, is this a ketone, is this an alkene, is this an alkyne, you need to choose the correct answer. Okay, A, B, C, D, 4 different answers, you may have to choose that. or if there is a question like which one of the following molecules is a, I don't know, something else, carboxylic acid. We will talk about that now. You will have to figure it out on your own, okay? So aldehydes and ketones are one category of compounds. And on the other side of the molecules, there will be 5 different compounds. I'm just going to write down their names because even though I haven't showed you the structures, it might make sense. The first compound there, so this is type 1, type 2. Over here, they're still under carbonyl, okay? Type 3 will be, I'm going to write it in blue, in red. They're called acid halides. Okay, that's type 3, different type of compound. Number 4 will be acid anhydrides. I just don't have the space to draw them right now. Acid anhydride, like no hydride, like no water, like dehydrated compounds. It's actually true. It's almost like you take 2 acids and you soak out, like you pull out a molecule of water, then you get an anhydride, okay? Acid halide, acid anhydride. Number 5, carboxylic acid, carboxylic acid, number 5. Number 6, ester. I'm going to draw it in black. Yeah, sure, black. Ester. I'm putting plural, so why not make all of them plural? Esters. And the last molecule is called amides. A-M-I-D-E. A-M-I-D-E-S. Okay, I call them the 5 guys. Don't get hungry. Don't think about the burger. 1, 2, 3, 4, 5, and 1, 2, altogether 7 types of molecules. These guys on the left, they do the reaction in certain way. These 5 guys on the other side, they do the chemistry that we're going to talk about, do it in a slightly different way. Okay, so let me take a picture. You guys stare at the board for me for 30 seconds, and then we will go from there. Then we will talk. Then I'll show you these 5 molecules. Then I'll erase the board and show you what these molecules look like. Then talk about the mechanism of the reaction, how the reaction happens, and what kind of business is going on with these molecules. Okay, they're pretty nifty molecules. They're pretty cool. I really like carbonyl chemistry. Okay. I should stop throwing my expensive antique phone. Looking good. You guys can handle it. If I make sure before you come on Tuesday, make sure that you guys are comfortable with determining or identifying an aldehyde from a ketone. If I draw something, you should be able to figure out this is an aldehyde, this is a ketone. So what if I draw this? Or maybe I'll replace the previous picture with this. What kind of molecule is this? If I ask you, what is it? Is it an aldehyde? Is it a ketone? Is it an acid halide, blah, blah, blah? Or is it something else? What is that? What is that compound? What category does it fall under? It's an A word. What is it? Forgot? They're under hydrocarbon. There are 3 kinds, one with no double bonds, triple bonds, one with double bonds, one with triple bonds. They all start with A. They end with A, something else, and another vowel. And the second category, the A changes to an E. The third category, the E changes to a Y. Ringing a bell? Ringing many bells?
Heptane.
Alkane, that's an alkane. Okay, very good. Just testing you because the final is not that far away. This is an alkane. What's that? Unmute and answer. I can't hear you when you're
Alkene.
alkene. What's that? It's the alkyne. It's the alkyne, Emperor. Right? Alkyne. Okay. What's this? It's not ethanol, but it's what is it? What functional group is that? I'm teaching functional group at the end of our semester. Usually a lot of people teach it at the beginning. It's an A word, ends with an L. What is it? Come on.
Alcohol.
Alcohol. That's an alcohol. I haven't been very discreet about discussing this, guys, but when you have an NH2, its great grandfather, atom of those molecules, is ammonia. When you replace the third hydrogen with something like a carbon chain, it becomes, it's also an A word, starts with an A, letter A, and ends with an E. What is it?
Amine.
Amine. It's an
Amine.
amine. Yeah, that's good enough. That's an amine. What is it? What is that molecule?
A ketone.
It's a ketone. Everybody knows it's a ketone. What is that?
An aldehyde.
Awesome. You guys passed the tests. Multiple tests, oral tests. We used to have them in elementary school. The teacher would call us up and we would really shake and they would ask questions, humiliate us. I felt humiliated. That's why I try to humiliate you. Just, revenge. Okay, everybody is good with what we have learned. I think so we just practiced it. No time to waste. Let's erase and let's talk about, I don't need this space right now. We don't need the alcohol right now. We don't need who we are right now. We are pretty lost in the world. Let that be there. Let this be there. Let's erase these molecules and let's draw. We already know it's carbonyl chemistry. We don't forget that fast, right? I forget pretty fast, pretty rapidly. Okay, let's draw the other molecules, the 5 guys. Don't think about what I'm thinking about right now. Peanuts and fries and something like a sandwich. All right, so let's see how the acid chloride look like. Let's start with the carboxylic acid, okay? Because a lot of times, what you want to synthesize in real life, they're these guys. These guys are the ones that are like stable, nice compounds that our body has a lot of these compounds. Cholesterol ester has an ester. The compound that gives the banana that specific smell, sometimes when you have too much of that, when 129A lab synthesize it in the real world, like real in-person lab before all these things happen, it fills up the hallway, the 3rd floor, especially the biology department. I don't know why they smell it more than we do. Maybe our nose is all plugged up anyway. Our receptors are not working anymore. So banana oil is an ester. Another molecule I wanted to, excuse me, aspirin, acetyl salicylic acid, that's an ester. Amides are everywhere. The proteins, they're sewed. They're basically amino acid, amino acid, amino acid, amino acid, 20 amino acids, different permutations and combinations. Then you have this humongous protein strip, which is kind of, that crawls and folds and does all funny business. It springs up. There is no word like springs up, but I just made it up. It takes the shape of a spring. Sometimes they're like straight chains. They're like railway lines. They can be, two of them can be side by side, and they're called sheets. They're called beta sheets. There can be four peptide strands parallel to each other. It's called a four-stranded beta sheet. There can be one sheet over another sheet. That's I'm not kidding. They're called sandwiches. They're called beta sheet sandwiches. So these structures and substructures are very important for proteins because the shape of the protein dictates its function. So if something goes wrong, like if this is how the protein is supposed to be, and let's say this guy kind of comes out of it, then that can cause a havoc. That can be the beginning of all hell breaking loose. That can start Alzheimer's disease. That can start mad cow disease. That can start Huntington's disease, Parkinson's disease. All these things can happen. And these molecules are very important, not only for building our body, like living system, they can also like trigger certain reactions. They can act like a catalyst, like a proton can act like a catalyst, H+. Certain proteins act like a catalyst. They have to be there for this guy to become this guy. For cholesterol to be synthesized from tiny little pieces, you need a 7-step synthesis, biochemical synthesis. Each step, there is an enzyme or a catalyst protein involved. Catalyst protein number 1 makes it from there to there. Catalyst protein number 2 makes it from there to here, then here to here, here to here, here to here, here to here. Finally, you have cholesterol. Cholesterol is important for multiple reasons. Cholesterol is also important for making other hormones like testosterone, progesterone, other many hormones. So this whole living system has like loads and loads of esters and amides. So amides and esters are really important. Drugs, molecules, like I always pick up this bottle because it's right here. Ibuprofen. Ibuprofen doesn't have any, why am I blacking out? Ibuprofen doesn't have any ester or amide bond. Tylenol, I don't have Tylenol here. It's in my man pouch. Tylenols have amide bonds. Lipitor, the LDL lowering agent, that probably has an amide bond. So the amide bonds and ester bonds are everywhere, okay? So usually we make these guys, when you have a research project, we are using DEET, the mosquito repellent, amide bond. That's a very simple, nice little molecule. Maybe I'll draw it up sometime today. It's a very simple molecule, and it'll make sense to you. Okay, that's one of our research projects. Actually, we are trying to make DEET-like molecules that actually repel a pest, not just mosquito. It's called spotted wing Drosophila. It's like a fruit fly that destroys healthy fruits, like healthy soft-skinned fruit, and it's everywhere in the U.S. right now. They came from Southeast Asia. I didn't bring it from India when I came here, but somebody else probably did it from somewhere. And they're everywhere. And the crop loss is like in the hundreds of millions of dollars. So we are working on that. We just filed a patent on that. So usually what you have on your shelf in the research lab is a carboxylic acid. And then you want to go to make an ester or an amide. That's your target molecule. But sometimes you have to make one of these two guys from this guy, 3 or 4 from number 5, before you can make the final compounds because of the reactivities. And I'll draw a hill. I always say the hill and the 5 guys sitting on the hill, like Huntington Lake, Shaver Lake, like, I don't know, there is a valley, maybe Aubrey, and then down at the foothill, okay? So I'll place the 5 compounds at different parts of the Sierra Mountains hill, and then it'll make sense to you. Like if we start from here, we roll up, then we develop enough energy to roll down all the way to an ester or an amide, okay? So usually this is the starting point. This is where you start. You sometimes go here, or you sometimes go here. Then the final destination is usually there, or final destination is usually there. You want to make either 6 or 7. This is a very practical view of these 5 compounds, carbonyl compound. This is because I have been in the field for a long time, more than 3 decades, and I've also worked in industry. So that's why we know, right? So I'm just telling you the secrets of the real world. Like we start from here, we sometimes go up or down here because they're very reactive, and we go down here. It's an interesting, you will probably get a kick out of it. So in nature, you find these 2 guys. In nature, you will also find acid. They're not terrible. They're a little reactive. They can be a little funny. They can have this acidic property. Acidic property means it can give up a proton, but they're not terrible. You will almost never, ever, ever, ever find an acid halide or an acid anhydride in nature. Nature never uses them, because if my body is made out of acid halide, like acetyl chloride, I will be very unstable. If you pour water on me, I'll probably disappear. If my entire body is made out of acid halide and some kind of an anhydride, I'll probably be destroyed just by seeing water or base. If you give me a bath in sodium bicarbonate or sodium hydroxide, I'm gone, psh, disappear. Okay, like one of those Superman, like who can become invisible. I will be invisible forever. Okay, so nature never uses them. Nature makes these guys for building stuff, making stuff, as a channel, as a gatekeeper to go through the membrane. They're called receptor proteins. They can, some proteins are actually in the nucleus of a cell. They're also called receptors, but they're called nuclear receptor. Their job is to start making protein, doing the translation and transcription. That's pretty cool, actually, if you take biochemistry. If you have that, if you still are interested in this sort of research, if I haven't completely killed your appetite, then you will find that pretty fascinating. So those are also protein, amide bonds. Okay. How much time did I waste? Quite a bit of time. 1:30, not terrible. Okay, let's draw some of these compounds. We already seen aldehydes and ketones. Acid halide, acid anhydride, carboxylic acid, esters and amides. I'm going to start from the middle. Okay, I'm going to start with carboxylic acid and then go up and down in the chain. I'm going to draw the carboxylic acid, maybe here. Let's draw a bunch of carboxylic acids. So let's draw the carbonyl with red. Let's draw the next oxygen in, because water is, I always draw water in green. I don't know if you can see it in the video, but then when I take the picture, if you're looking at the picture, all the colors will be pretty vibrant. O on the left side, let's put the smallest thing. I already told you the left side has to be hydrogen or carbon. Let's put a hydrogen in this case. So we are again going through examples of these 5 different types of functional groups. Hydrogen, carbonyl. So carbonyl, I picked hydrogen. On the other side, I picked oxygen. What can be on the other side of the oxygen for it to be a carboxylic acid? Anybody wants to take a shot at it? What should be here for it to be a carboxylic acid? Anybody wants to take a shot at it? Man, our strength today is very small. 5 of, how many of you are there? 15, 16, 17, 18, 18. Okay, that's fine. I'm not complaining. Everybody's too tired. What shall I stick here? End up that green stick in order for it to be a carboxylic acid. Any idea? H. Okay, so this is a carboxylic acid. Carboxylic acid. This particular carboxylic acid. So what makes a carboxylic acid carboxylic acid? Well, this whole thing It's the COOH that makes it carboxylic acid. So a carboxylic acid has COOH. When I was a general chemistry student back in India, once upon a time in the 17th century, when Alexander was running around, okay, it was probably shown as CO2H. And I hated that. I said, really, I have to memorize CO2H and C3OH7, whatever. And, you know, glucose was what? C6H12O6, all that stuff. And I absolutely hated it. I did not like general chemistry. But when I see the structure, it makes sense. I can do it. I don't have to memorize this stupid, this number of hydrogens and oxygens and CO2 and C6 and C9 and N5 and N3 and all that stuff. It makes sense. So carboxylic acid must be CO, double bonded oxygen, one of them, carbonyl. Another one is single bonded H. That's carboxylic acid. This particular carboxylic acid, when you are bitten by the smallest insect or living creature in the world that has existed since the ancient time, that name of that insect has 3 letters, starts with an A. And when it bites you, when it stings you, it gives you a small injection of this particular acid. It starts with F2, not F2. It also starts with the letter F and then acid. It's very much like that thing that you smell, the aldehyde you smell in a hospital, formaldehyde. Formaldehyde has 1 carbon and this acid has 1 carbon. They're kind of like distant relatives. What's the name of this acid the ants inject you with? Anybody? Something acid, the first word starts with F. No, we don't know. I won't tell anyone. I think some of you are almost remembering, but can't remember. Okay, this is
it formic acid?
You're on a roll, lady. That's really impressive. Formic acid. Very good, thank you. Okay, so this guy, remember, now you can connect the dots. When you have this guy, like a completely different species from here, now it'll make sense to you why that guy is called formaldehyde. We just learned it. Formal, form, okay? Form, and here form. That's formaldehyde, and this is formic acid, carboxylic acid. So maybe you can connect the dots and have some nightmares tonight. Welcome, thank you. That's formic acid. Let's do another carboxylic acid that's also very common. And when you open up a bag of chips like a monster, sometimes when I come home and I open up the fridge, there is like nothing that I can eat immediately. Then I open up the cabinet, I scan the cabinet, there is nothing there. Find a bag of chips, I'm like, rip it apart and start like jumping in it and eat like I have not eaten like in a month. And the sour taste comes from that particular acid. That's also a very similar carboxylic acid. You know what? Let me draw that guy over here, because otherwise I'm going to make that part extremely crowded. That acid, let's see if anybody remembers the name of that acid. That acid has the acid thing, okay? This is the acid thing. Somebody would fire me. Like, Dr. Maitra Shantanu, you don't qualify to be an instructor anymore. The functional group, and on the other side, instead of having a hydrogen, it's got a carbon, the smallest carbon thingy. That's the methyl group. That acid is called, the trivial name when you buy a bottle of The V thing to make things sour when you're cooking something. What's that V thing? Starts with V and ends with R. Come
Vinegar?
on, you know it. What? Vinegar. This is vinegar. Does anybody know what that name of the acid is? It starts with an A. AC.
Acetic acid?
You should buy some lottery tickets tonight. Acetic acid. You must have secretly read the book and pretending that, oh, Dr. Mitra, I don't know, I'm just saying random names. Acetic acid? No, I'm just kidding. You know. Very good. Thank you. So that's vinegar. Any other acid that's interesting? I am really tempted, but I don't want to get distracted. I want to finish something. It's already 1:22, and I'm obviously putting some, dramatizing things and wasting time. So let me erase some of these name things so that we have a little more space here. Okay, so that's carboxylic acid. That's this guy. That's number 5, compound number 5. Let's draw and let's go backwards. Let's go up the hill. This is Auberry. Okay, we're going to draw something at the foothill where we live, where civilization almost ends. Okay, 165, 160, 160, 165. For a second, I had a blackout. Like, what's the name of our freeway? 165. 165, right? So 165 and Shepherd. And now let's draw something at Huntington Lake. Now, at Huntington Lake, what you have is this guy, acid halide. So what would it look like? It's pretty simple. Let's make the formyl chloride. So hydrogen, carbonyl, and on the other side, if this is formic acid, and if that is formaldehyde, formyl chloride will be the first acid halide example. And what shall I draw here to make it formyl chloride?
Is it a chlorine? Yeah.
Absolutely. Absolutely. It's that simple. Like an insurance agent. It's that simple. Call me. I'll get you money. I'll take your money first. That's formyl chloride. Okay. Fantastic. That's an example of molecule type 3. This is type 3. Okay. That guy is type 5. Now, formic anhydride. Now, you know what? Let's spice it up a little bit. Let me just draw the molecule. We need this. We need to draw the Shaver Lake. So this is Huntington Lake. Shaver Lake will be down here. So we can have the name there. So this guy is called what? This guy is called formic acid, right? Formic acid. Okay. I'm not going to ask you to draw the formic anhydride. I'm going to ask you to draw the vinegar anhydride, acetic anhydride. Let's see if you can do it. So if I say that we are going to draw the acetic anhydride, the anhydride from acetic acid, 2 molecules of acetic acid at Shaver Lake, little below Huntington Lake. That's going to be compound number 4. So we're going to draw ACE, TIC, ANHYDRIDE. Let's do the experiment here. How does acetic anhydride happen? I told you anhydride, N means no. It's like dehydrated acetic acid. It's like taking 2 molecules of acetic acid and sucking out a molecule of water. That's a chemistry. I'm not making it up. It's a real chemistry. So let me show you what I'm trying to talk about. So let me draw 2 of these acids, 2 of the vinegar molecules. It's pretty cool, actually. I'm not sure if acetic anhydride is used for cooking. It might be. I know that it's not bad. Acetic acid is pretty good. Not like you can drink it, but a little bit is okay. That gives that taste. So you take one acetic acid and you take another acetic acid, okay? And it'll make perfect sense to you pretty soon. Another acetic acid, I'm kind of sticking it in there because I need that space. I'm drawing it backwards. I don't want to jinx it, but do you realize that the camera has been behaving pretty well? I don't know, maybe I didn't go to the corners. Let's not jinx it. I think it's also happy that the semester is coming to an end. It can take like a little, go on hibernation. So acetic acid molecule number 1. Acetic acid molecule number 2. So acetic anhydride is 2 molecules of acetic acid minus water. How does it happen? Like this. You take this hydrogen and you take this entire thing with the bond, electrons. You take that you get rid of that molecule. So what am I losing? OH with the bonding electrons and the proton. That means that essentially means water. That means H2O. 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 I'm sucking out a molecule of water. So when you do that, when you remove a molecule of water, I'm going to draw this molecule exactly like that up there. Okay, just let's go from there. So a methyl, a carbonyl, okay, green oxygen. The other side of the bond has survived because you just plucked a proton from here. And then you got rid of this whole OH minus, OH with the bond. So what should be attaching to that green oxygen? But the carbonyl, the second carbonyl, okay? So the second carbonyl goes there, and the methyl group. This molecule is acetic anhydride. I'm going to write it down like the way we just performed the surgery or the torture. We took 2 molecules and removed the molecule of water. I'm going to just call it dehydrated acetic acid, just so that it makes more sense. Dehydrated acetic acid. That's not what it's called. I'm just trying to make more sense to you guys about this molecule so that when you see an anhydride, you don't freak out. So carboxylic acid, acid halide. What's the acid halide functional group? What would you call an acid halide? This thing. That's the acid halide. That's the acid halide functional group. Carbonyl, on the left side, hydrogen or carbon. On the right side, one of the 4 halogens, fluorine, chlorine, bromine, or iodine. Make sense? Acetic anhydride, what's the functional group? What is the anhydride thing? What is anhydride? Well, carbonyl, oxygen, another carbonyl. This whole thing is the anhydride functionality. This basically means 2 carboxylic acids, squeeze them, slap them together, a molecule, a drop of water falls out, you got an anhydride. So any compound that likes to soak up water, if you take acetic acid, vinegar, and if you put that dehydrating agent, you will make the anhydride. It's pretty cool. Very, very interesting. Okay. Carboxylic acid. So compound 3, compound 4, compound 5. Let's draw an ester. Let's make a simple ester of the formic acid. So these guys, their reactivities are very similar. So I'm going to draw them at the same level. Okay. So it's going to be looking almost like acetic acid, formic acid. Let's make an ester of a formic acid. Let's make a Sorry, I hurt my ankle earlier. Let's make a methyl ester of formic acid. Okay. So everything is pretty much like formic acid, except you can't put that hydrogen anymore. The moment you put the hydrogen on the single bonded oxygen, it's a carboxylic acid. In order for it to be an ester, it cannot be a hydrogen. It has to be something carbon. Anything carbon, methyl, ethyl, cyclopropyl, benzene, doesn't matter. Okay. So I'm just going to put the simplest group here. Methyl ester of formic acid. There is a name for it, methyl formate. I'm not going to teach you that. Let's forget about that. These dudes are called. So these are anhydrides. Sorry. So let's write down. These are acid halide. Acid halide. That's the functional group. Acid halide. These guys are called anhydride. And these guys are called carboxylic acid. It's already written, formic acid. These guys are called esters. Ester, number 6 in the list. Okay. Finally, an amide. Let's make a formic amide. Formamide. Okay. What would that guy look like? It's near our house at the foothill. Carbonyl. Let's make a formamide. So it's going to be starting from the formic acid. So I'm going to put a hydrogen on this side. On the other side, what do I need to have? For an amide, amine, nitrogen. Okay, am means nitrogen. So a nitrogen here. I've been drawing nitrogen with blue. So we have covered this. We have covered this. We need to cover that, the nitrogen guy. Okay. So I'm going to draw nitrogen. And on the other side of the nitrogen, you can have hydrogen or carbon. So let's stick with the smallest. This is the smallest amide. This guy is called formamide. And this class of compounds is amide. Putting the name of the functional group in a box. And this particular guy is called formamide. Okay, because it's a formic acid derivative. It comes from formic acid. Formic acid, formic acid. Where is the aldehyde? Formaldehyde. This is formyl chloride, and that's formamide. Let's draw another amide of acetic acid. Let's put methyl groups everywhere. Another example of an amide. Let's draw it down here. From acetic acid, from vinegar. Carbonyl. I'm not drawing the carbon here. In order for it to be an amide, it has to be a nitrogen. Okay. Instead of sticking hydrogen, let's put some methyl groups. I'm not going to draw the name of the molecule, write down the name of the molecule. You don't have to know that, but this is also an amide. So what's an amide group? So this is a formyl acid halide functionality and hydride functionality. This is a carboxylic acid functionality. Acid, that's the proton that the acid is going to spit out like a snake spits out venom. That sounds too harsh, sorry. This is an ester. What's an ester bond? This is an ester bond. As long as what's stuck to the oxygen is not a hydrogen, is a carbon. This is important. It must be a carbon, not a hydrogen. What's an amide bond? Amide functionality. This is an amide functionality. Carbonyl, and all you need to do is put a nitrogen next door. That's it. That's your amide. Okay, so we have pretty much covered. Where are we with time? 1:35. Okay, we have 10 more minutes. Okay. So these are the different functional groups under the carbonyl. Let me introduce you to the chemistry, and then we can wrap it up on Tuesday. Okay, so let me take a picture. So what we have done so far, we have just given you a glimpse of, well, you might be wondering, like, if this is glimpse, I don't know what's coming after the glimpse, the real exposure of the frame. So we have showed you what an aldehyde looks like, what a ketone looks like, acid halide looks like, acid anhydrides look like, carboxylic acids, esters, and amides look like. You better memorize what they look like. You better be able to identify an ester from an amide, from an anhydride, from an aldehyde, ketone, things like that, okay? Make sure you guys got it under control.
So the amide, it's just like, so I know you said it's connected, the carbon connected with the nitrogen. So is it just nitrogen? So like the.
So are you talking about the amide?
Yeah.
So amide, you have to have a carbonyl. That's the basic fundamental requirement. There has to be a carbonyl. On one side, hydrogen or carbon, whatever. Okay, like over there is a hydrogen, over here there's a carbon. There could be a benzene ring on this side. It doesn't matter. Look for a carbonyl. One side carbon or hydrogen, other side nitrogen. And on the other side of the nitrogen, you can have hydrogen, two of them. You can have methyl groups. Something carbon, you can have one hydrogen and a carbon, anything goes, okay? The bottom line is carbonyl and a nitrogen, that's the amide functional group.
Perfect, thank you.
No problem, okay. Let me raise the board and let's talk about just a little bit, whatever we can cover in like, now it's 8 minutes probably, 7 minutes. Okay, so the chemistry of carbonyl molecules. Let's see how much we can cover today. Not a whole lot. So when you have a carbonyl compound, I'm going to go back to my cartoon diagram of carbonyl molecules because it could be any of these 7 different compounds. So let's not get too biased about dealing with one of them. Let's keep things very general at this point. And let me show you the general chemistry, like what happens in this business. Okay, then we'll wrap it up on Tuesday of coming week, and that's it. And don't forget that there will be a review on following Friday, week from tomorrow at 7 a.m. And it will not be recorded. Okay, so a general carbonyl molecule. I'm going to draw it really big. You already know what has to be here on or there. I'm going to put like a little round shape and shade it out, the shady area of the molecule. On the right side, we'll put some other color. I don't know what color, but purple. Let's put like a little rectangle. Something. So you know what they can be. It can be hydrogen and hydrogen. It can be methyl and a hydrogen. It can be C and C, C and O, OH, O methyl, halogen, O then carbonyl, then something else, anhydride. It could be a nitrogen with something, an amide. So all these possibilities, 7 possibilities. Now, what does it react with? You know that this molecule, if I draw the Lewis dot structure, that didn't sound like a happy molecule, it's whining. Sigma bond, let me finish before I get to the types of bonds. Okay, this is how the molecule looks like. This is the vulnerable bond. This is the pi bond. This is the sketchy area of the town. Okay, what can happen? Well, oxygen is more electronegative than carbon. So there is a chance that if it gets pushed, that pi bond can move. The pi bond is the sketchy part, the vulnerable part, the most attackable location of the molecule. The pi bond can break either way, and if it has to break, it'll probably break in a way that it can go toward oxygen, because oxygen is more hungry. It's more electronegative for electron pair in a molecule, in a bond, more electronegative. Oxygen is 3.5, carbon is 2.5. So bond breaks there. So what can come and push, give that nudge? Something like a nucleophile, water, alcohol, ammonia, amine, anything that has lone pair or a negative charge, or carbon minus. If you could make like a C minus, that could be a great nucleophile. If it could make an H minus, that's a fantastic nucleophile. So if you bring in a nucleophile, some nucleophile, it can come and attack. This is the electrophilic center, and it can completely destroy the double bond and push the pi bond on top of the oxygen. Okay, that's how the ordeal may start. Ordeal, or maybe it's a good thing to make a brand new fancy molecule. Who knows? Okay, so let's see what happens after this attack happens. The attack happens. This guy is in sp2 hybridization. It's a flat planar molecule. The carbon or hydrogen, whatever here, the carbon in the middle and the oxygen, they're all planar. sp2, sp2 and sp2 bond, sp2 and whatever, sp2 and whatever. This is P and P, side to side overlap. Pi bond. For the final, you will need to know everything that we have learned this semester. So once the attack happens, let's see what happens to the molecule. Well, the sigma bond survives. The pi bond doesn't survive, man. Unfortunately, I'm sorry. Don't push me. Okay, that bond is now on top of the oxygen. Okay. What's on the other side of the molecule? Well, this guy here, what color is it? This is what happens when you use too many colors. You just slow down. And I used slanted lines. That's the net. And there is a purple box here, jewelry box. Not that I care. I could care less for jewelry. Nucleophile in. And this guy is negative. This is called, it was not tetrahedral. Right now, you got a carbon with 4 different things attached. This is called a tetrahedral intermediate. This is how the destruction of the molecule starts. Nucleophile comes and attacks the carbonyl carbon, pushes the pi bond on top of the oxygen. This thing happens, and then it can do 2 different things. It can try to do something cheesy, which is path 1. This is path 1. In path 1, and I'm going to color code it path 2. In path 1, what happens is, let's say what happens in path 2. In path 2, the red color arrow, so I'm going to use red. In path 2, the lone pair, the extra lone pair kicks back and kicks out whatever is on the right side of the molecule. This guy is pushed out. If it is pushed out, that means must be a good living group. This guy must be a decent or good or bad living group. It has to be a living group for this business to happen. So when this happens, the carbonyl regenerates. Okay, carbonyl regenerates. Whatever you had on the left side is still there, hydrogen or carbon. On the right side, something has happened. Whatever the molecule was born with is gone. but something new has come in. This guy, the nucleophile is in a different molecule, and that box is out. That living group is out as a negatively charged species. That's one type of reaction. In the second type of reaction, there is no living group. The living group sucks. Whatever the molecule was born with on the other side is not a good living group. It's a terrible living group. Okay. In this case, living group is there. Living group is present. Good, bad, ugly, whatever it is. Just stay for 1 or 2 more minutes. Over here, no living group. No living group on the right side. You have something that doesn't want to be kicked out. Extremely uncomfortable to be out by itself. Very unstable, very reactive. It will not leave the daddy and the mommy's shadow. It's going to stay in that room. You can't kick it out. Okay, no matter how great the nucleophile is. So in that case, what will happen? Well, nothing will happen unless you neutralize that thing, negative charge, with something simple. What can you bring in to neutralize it? Well, how about something like this? How about you bring in some weak acid, H+, like dilute HCl, because HCl produces H+. So it picks up the proton. Nothing has to be kicked out because nobody wants to be kicked out. Everybody wants to stay in the molecule, okay? And the carbonyl doesn't look like carbonyl anymore because it has picked up a proton from here. This was the second step of the reaction. First step was hitting with a nucleophile. Second step was adding some H+ to make the O- neutral again. That sounds like a political slogan. Okay, so the round thing is there, hydrogen or carbon. It can't leave. On the right side, it was born with whatever, something else. We're going to discuss it on Tuesday. Something not a living group. This is not a living group. And the nucleophile is in. And that guy, everybody is in. Nobody got kicked out. So this reaction, generally the reactions are called nucleophilic. This group is not called carbonyl, it's called acyl. Nucleophilic acyl. One is called substitution and one is called addition. Which one is called addition, top or bottom? One of the reactions up or down is addition, and one reaction is called substitution. Which one is addition, the blue reaction or the red reaction?
The blue reaction.
So these reactions are called, this is the last thing I'm going to write, and then I'll let you guys go. So nucleophilic, acyl. When you hear the word acyl, think carbonyl. Acyl, think carbonyl. Two reactions, either nucleophilic acyl addition or nucleophilic acyl substitution. Okay, so remember that, and we're going to do a few examples on Tuesday. Take a very small quiz. I might keep it like really small, and then we'll have our review. Then we'll have our final, and then you guys will be free, like birds freed from the cage. All right. I'll take a picture before I forget, and I'll make everything available as soon as I can. I took a picture, and that's it. That's all I had for you guys today. Let me move to the front camera. Any questions? Any concerns? You guys are hanging in there? Hi, Catherine. You're on my screen right now for whatever reason. Maybe you made some noise. That's how you got picked up. Hi, Ivan. Hi, Angeles, Allison, Carlos. Catherine is already there. Vincent, Hardeep, Eduardo. How are you guys doing? Any words? What's your plan for the weekend? A little bit of studying, okay? Don't just blow the weekend completely. Please study a little bit. You guys are hanging in there, so that sends me a signal that you guys are serious about it. So do well. All right. All right then. Bye. Have a good weekend.
Thank you.
Okay, there is something on the chat. Okay. Okay. All right. Bye. Take care. Have a good weekend. Study a little.